is coming from. Very nice to see such a large crowd and from all over the world. Welcome to this webinar. This is part of the Solar webinar series, which we've been hosting for over a year now already. And it's organized by the Society for Learning Analytics Research. We offer this webinar series as a way to make a range of topics more readily available to the community. And we also record these sessions to serve as a kind of database of resources for people interested in learning analytics topics. And yeah, we are your hosts today, Vita, myself, and Isabel. We are on the Solar Executive Committee. And well, some of you, I see some names that I've seen before. So some of you have been joining us before. And what you're used from us is that we normally invite researchers to present about their work, and then we have a Q&A discussion about the presentation. But today we have a different format, and we have so it's a special episode where we have a panel instead of a presentation and a discussion. We're very happy that the editors of the Journal of Learning Analytics approached us and collaborated with us to set up this session, where we will have a panel about the important topic of rigor in learning analytics research. And editors have created a set of panelists that will tell us about rigor in analytics research from different perspectives. And we will also have time for Q&A about this topic. So we're very excited to experiment with this setup with you. And we now first go to Vita to explain some of the communication rules in this Zoom meeting, and then we will start with the panel. So Vita, can you give us a brief update on the communication in Zoom?
Yeah, so really, so to run things smoothly, first of all, couple of things. So your camera and Microsoft, your cameras are turned off if you're an attendee, and as an attendee you will be able to raise your hand eventually to ask questions when it's time, and also you will have a Q&A button where you can post your questions. So you also have chat, but make sure when you're using chat function to change to that your message is shown to all attendees and panelists. Otherwise it just goes to panelists. And yeah, so that's you will be, when it's time for Q&A, you will be able to unmute your mic and then ask a question, or you can type your question if you want. So much about that. Anouschka?
All right, then I suggest we give the floor now to the editors of the Journal of Learning Analytics, who will shortly introduce us to the topic and also introduce us to the speakers.
Great, thanks so much, Anouschka and Vita, for the invitation to run the session, and to everybody attending as well. It's really nice to see such a large number of people and from all over the world. One of the advantages of being able to do events like this remotely. You'll see I'm just sharing the results of that poll as well, which really shows the richness of perspectives or sort of disciplinary traditions that people are drawing on. And the diversity of backgrounds that the learning analytics community draws on is one of its biggest assets, I think. Brings a richness to the field and significant methodological innovation. And the reason that we put together the panel, this panel, and a series of events that we're hopefully going to be trying to run afterwards, was because when we're thinking about outputs through the journal, one of the things that we care about fostering, and that the community cares about more broadly, is supporting impact, and an aspect of that is rigor. And we know from our experience as editors that we've had conversations with members of the community about disagreements between reviewers, whether or not work might pass muster in other communities, and the sort of suitability and questions we ought to ask around that. and trade-offs between, for example, model goodness of fit and usefulness, so actually achieving change in learning, and what our sort of metrics of success might be and the implications of that for Rigour as well. And this all sits in a wider context of discussions in academia more broadly around transparency in science and the open science movement. We have had contact from people in that movement around questions like whether the journal should ban p-values, and there are other concerns like that that are very live. And of course, we've made some changes to the journal over the last few years to do things like introducing sections to speak to particular parts of the community and try and foster cross-community communication. And these all fit together. So the purpose of today's panel is to think about, well, what are some of the hallmarks of Rigour in the different traditions? To what extent should we be hoping that people will agree, particularly in contexts like reviewing? And how should that happen? How should we foster that? And where might there be interesting tensions? At the end of the session, we'll have time for Q&A, and we'll also be launching a Google form survey to ask people about some follow-up sessions. And we're particularly in those sessions interested in looking at what are the policy levers that we would be able to pull as a journal in our editorial policy to foster Rigour across the community or communities and traditions that the community draws on. So that's enough of an introduction from me. The format for the session is we have three sub-panels, each with 2 people speaking on them. And we're going to start with 2 panelists talking from a statistical tradition, Sandra Milligan and Phil Winne. Sandra is the Director and Enterprise Professor at the Assessment Research Centre at the Melbourne Graduate School of Education. And her research areas are on assessment, micro-credentialing, and big data to support assessment of higher order learning skills. And Phil is a Distinguished Professor of Educational Psychology and former Canada Research Chair in Self-Regulated Learning and Learning Technologies at Simon Fraser University, Canada. And his research interests include self-regulated learning, metacognition, motivation, and use of adaptive software to promote self-regulation. So I shall hand over to Sandra now. Thank you.
Thanks, Simon. Look, I've decided to take a fairly strong position for the purposes of discussion this morning. And Phil, I'm sort of hoping that you won't agree with me so that we can have some good discussion. I mean, basically where I'm coming from is that I do not yet think that learning analytics as a discipline has sufficient standards underpinning it for it to be respected as a discipline that can be trusted to have impact, particularly in my field, which is education. I know that there are arguments that learning analytics is very complex, that it's cross-disciplinary. I mean, already in this group, we can see we've got statisticians, computational experts, qualitative people. We've got people who come from education. It's a very diverse crew. And the argument is, well, when you have such diversity in perspectives, you're going to get diversity in standards. And you can't expect reviewers to all agree and that a common view of what's good quality to come through. I take a different position and say, well, for all of those reasons, I believe we must have common standards. Otherwise, the impact will never be there. So I guess the question is, where would you look to find these common standards? My argument is that you look to the place where every discipline looks, and that is to the application of the tenets of scientific inquiry. And they're things that have lasted us for centuries, and they're the things that our universities are built on. And I believe that they're the tenets that the learning analytics community should take to its heart before we're going to actually get strong impact. The sort of things I'm talking about when I talk about the tenets of scientific inquiry are things like, you know, the quality of the connection of your work to the existing theory that you're working in. So, you know, if you're talking about feedback to learners, you shouldn't just quote Vygotsky 1926 and Hattie 2009 and say feedback counts. You've got to go into what feedback counts when it's got positive impact, when it has negative impact. So the quality of the connection to the learning theory, I think, is something that we should work on. The second thing is the suitability of the data, because the fact of the matter is the data has to have construct relevance, and quite often it doesn't. I mean, I'm happy to give examples of where we've got MOOC data, I think is quite a good example of that, where we've got masses of information, but really it doesn't actually connect with what we know about learning. Another area is that I think we need to have standards on is our conception of what learning is and how that manifests in our models. For instance, learning is growth. That's what learning it is. You start somewhere and you move on. So many of our studies define learning as the rank order of a final assessment. That's not learning. That's just a rank order of final assessment. And until we have an understanding that learning is growth and that we're modeling growth, I don't think we will have hit the right tune. And look, I'm just going to stop now, but finally, one of the tenets that I personally hold most strongly, and I often don't see in learning analytics writing, is that your findings are one thing, and it's good to represent them, but perhaps more important than that is your willingness to have doubt about your findings, to seek disconfirmatory evidence that you might look at, to look for misfit to your models, and to look at the consequences of having your model. Now, those sorts of issues like misfit, consequences, doubt, they are fundamental to scientific inquiry. And unless an author or an analyst has worked through how they bring doubt, misfit, consequential analysis, and all of these things into their analysis, I don't think that we're going to be trusted to have the impact in the real world that we really want. Why don't I just stop there? There should be enough there for Phil to disagree with or bounce off. So over to you, Phil.
Thanks very much, Sandra. Sorry, I'm not going to disagree very much, but I want to start with a little levity. One of my favorite sayings is that statistics means never having to say you're certain. And I think that's an important point for us to remember. And I also often begin these kinds of exercises in looking up the definition of rigor. And I was kind of surprised this morning to discover that it's a sudden feeling of cold with shivering, accompanied by a rise in temperature, offering with copious sweating. So I don't know whether we want our editors or our experimenters to experience rigor in this way. But what we're really talking about, I think, is the quality of being thorough and accurate, exhaustive and precise. So I want to to mention what I think would be 4 steps toward thinking about rigor that kind of the launch point for this is thinking about what's a goal for learning analytics. And I'm going to put something I think might be a little provocative out for this statement. I think it's so that we can accurately, and I want to add responsibly, predict achievement and motivation from event data so that we could dispense with, get rid of tests and surveys. Can I tell whether you've learned by just observing what you do as a learner and how you feel about yourself as a learner by just looking at what you do? That's what I think learning analytics might strive to do. And to get there, we of course need to gather data. And so my first point is that when we select data, we have a reason for selecting particular data. A phrase of mine that I also like from a book, the title is very provocative, although I haven't read much of it. It's called "Raw Data is an Oxymoron." There are no raw data. We have perspectives that guide us in thinking about our data. And so I think we should carry that same question over to our statistics. How do we dig into the underlying qualities of statistical work that we do? So when I teach our multivariate stat course here, I say to students, you know, the linear model is not as complicated as you think it is. Here's how you know all about the linear model. How do you compute what you know about a person given their answers to multiple choice questions? And people say, well, you score them 1 and 0 and you add them up. And I point out, do you notice you could put a 1 in front of the 1 or 0 and multiply the score? You've just constructed weights for your linear model. Have you ever thought that one of the questions on your multiple choice test was more important to knowing the topic than another one? What we're going to do in the linear modeling is figuring out, should we use 1? Should we use a different number? And so the point of this little story is to think about what's implicit in our work, the things that the statisticians just skip over because it's so common. We think about weights for things, but we don't, for instance, necessarily give thought to how are we estimating those weights? What would be the ways in which we could reveal for our readers the metrics we're using to determine the impact of residuals, which is another way of asking the question about what the weights ought to be. Another question I think we need to give thought to is moderators for populations. Every experiment I ever read in my field describes a sample, the proportion of males and females, the age, the ethnicity, the language. And this irks me a lot because almost never are there any documented results showing that these are genuine moderators of what people are looking at. So I think we should give more thought to how we explicitly pick our moderators. Again, they're not raw data. Very quickly, just 3 more steps or points. I'm going to put a couple of articles in the chat in a minute, but one of them is an editorial statement from the American statistician by Wasserstein et al. It's called "Moving to a World Beyond P less than 0.05. And the short message of this article and then the rest of the special issue is avoid using P levels. And I'll just let that article and the special issue speak to all the reasons why we should entertain that. The next step I want to mention is a replication interval. And this will be one of the articles that I'll put into the chat as well. I just want to give you an idea about what this is like. Suppose you do a randomized controlled trial. It's exceptionally well done. And you observe an effect size that's, for instance, a correlation of 0.3 or a Cohen's d of 0.63. Those are equivalent. Now imagine an imaginary world. We could use exactly the same sample with no carryover effects and do exactly the same study. What would you expect to observe for the effect? Well, remember we start out with R equals 0.3 or a Cohen's d of 0.63. The interval is somewhere between R equals minus, let me read this here, minus 0.33 to plus 0.65. So the point about rigor here is to entertain the idea of what Stanley and Spence call a replication interval as a way of qualifying what you're reporting about your experiment on the way to using event data.
Sorry to interrupt. 5 minutes have passed. Sorry.
Okay, I'll come back to the next step if we have time.
Okay, thanks, Sandra. Thanks, Phil. For the second panel on perspectives on Rigour from the computational approaches, I have the pleasure to introduce you to eminent researchers in the field. First of all would be Dragan Gasevic. He's a professor of learning analytics in the Faculty of Information Technology at Monash University, Australia. And he's a former president of the Society of Learning Analytics. His research interests include developing computational methods that can advance understanding of information seeking, sense making, and self-regulated and social learning. Our second panelist will be Jelena Jovanovic. She's an associate professor in the Department of Software Engineering, University of Belgrade in Serbia. Her research interests include the use of statistical machine learning methods and techniques, semantic technologies, and other computational approaches that combine human and machine intelligence to improve understanding on the learning process. Please, Dragan, the floor is yours.
Thanks very much, Xavier, for the kind introduction. And also, it's my pleasure to be part of the conversation here. I'm going to basically continue with some of these points. I can see, based on the declaration, that the computational aspect is probably at least represented, at least according to today's audience's poll. So I'll try not to be very technical. I'll try to be generally kind of broad in my claims, still trying to cover some relevant ground. When we are talking about computational methods in the field of learning analytics, we are predominantly really referring to the points related to machine learning, to natural language processing. To a certain extent, more recently, we are also talking about process mining or sequence mining, and we are talking about network science. I'd say that when we are talking about the rigor in many of these aspects, the majority of the things that we are discussing about is related to some level of predictive or descriptive modeling of the phenomena that we are trying to study. Obviously, one of the critical steps in that process is basically going from this raw data, as Phil said, as an oxymoron, going to that basic type of data that we initially collected to something that we want to include inside of our models. In some of the literature in learning analytics, that step is typically called feature engineering. And that step is often, I'd say and argue, in learning analytics, fairly insufficiently consistent and transparent, meaning that we really don't have clarity sufficiently how some of these features are extracted, even in some cases, which features are extracted, and more importantly, the reasons why some of these features are extracted. So I'd basically argue that it is really essential for us that we answer these questions of how, which, and why these features are extracted. And more importantly, also for the sake of the rigor and transparency, I think that even step of extraction of some of these features and the scripts and the source code for data analysis used should be shared as the critical one as we are going forward with this. Otherwise, what is happening in many studies, we are all basically extracting some of these features and variables slightly differently. They are in a way trying to model the similar phenomena, but they are not really sufficiently represented. And obviously, speaking back to some of the points also Sandra mentioned, some of our choices needs to be also justified conceptually and theoretically. Otherwise, it's really kind of hard to justify why we are including certain features. The second series of choices that we need to make when we are going is really with the use of computational models is the need to do fair bit of justification. We need to really take this kind of step of justification of the choices we are making with respect to the relevant educational research questions we have and the theoretical or conceptual models that we are using. And that's often not really sufficiently done. So we need to basically be very clear with respect to the choices of the methods that we are using for particular tasks or research questions and the parameters that we selected or decided to tune inside of these models. That's really often not sufficiently tackled. Then we also need to be very clear with respect to the choices of the data sets that we are using. And as I said, also, I'm going to reiterate this point, there is obviously a need to have a good alignment with the theory, but there are certain situations where that alignment with theory needs to be done at the level of not necessarily to white box everything, but certain things like the outcomes should be clear, inputs should be clear, but then we don't necessarily have for every task explainability. And I understand that this is a bit controversial, but I'm going to take the example of, for example, speech recognition. We don't necessarily need to have speech recognition explainability every time, but as long as we see obviously that our speech is recognized accurately, meaning that we have good level of reliability and we can trust these type of models, that we are also producing something that is very valuable for computer science. And I think that's really something that we haven't really tackled sufficiently in the field of learning analytics in that extent. And there is another series of issues that we need to pay attention to with respect to computational, and that is the level of validation. I think we don't still have sufficient level of rigor. First of all, we often have relatively small data sets. And then when we have small data sets, we need to think about how we can prevent some level of data contamination, especially when we have certain data sets that are unbalanced. So for example, we have certain classes in our outcomes that are underrepresented. So how we are doing that, basically balancing of the classes, and more importantly, how is that done when we need to basically have relatively small and underrepresented class in our data? Then we often do some basically oversampling of that, but then whether that is contaminating our data is really a critical thing, how we are addressing that. There's another thing that we really need to think about, and that's basically generalizability when we are thinking about computational methods. Ryan Baker had a beautiful keynote at Lyon 2019, addressed some of the major issues when it comes down to generalizability, but I'm going to really try to emphasize here two key points. The first one with respect to generalizability is really making sure that we are really not overfitting our data. And that really typically means trying to test our models on unseen data. Often, if you are trying to apply your model, for example, in a data collected in a particular course, then there was a really nice work by Chris Brooks and Josh Gardner a couple of years ago in JLA, which basically indicated that we need to take future courses, future editions of those courses, not trying just to use tenfold cross-validation, that we are trying to basically kind of sample that within the same course. But I would also argue that our generalizability need to be meaningful conceptually. So if we already can make a claim that certain things cannot be really generalized over certain contexts, then we should not be forcing our models to do something like that because we know that's not particularly relevant. I'm here referring, for example, to the different instructional conditions that are driving the decisions that learners are making, and therefore the observed behaviors or the types of activities that students have, as well as any additional judgments that we may ask them, may not be particularly accessible, and thus we cannot really try to generalize.
Sorry to interrupt. 5 minutes have passed.
Sounds good. I'm going to stop at this point anyways, and thanks for the attention. Jelena, over to you.
Okay, thanks, thanks Dragan, and thanks everyone. Well, I'll probably just try to add some things that Dragan still didn't have time to mention, and I do not have any contentious points with him. So maybe something that I want to, let's say as the first thing is when considering this rigor in relation to computational methods and what we have mostly done in relation to machine learning methods is that there can be it can be considered from two aspects. So rigor in terms of rigorous application of computational methods on one hand, and on the other hand, rigorous reporting or representation of the adopted method and the study results. Dragan covered many things related to this part about rigorous application. I would just want to stress one more time that we should always, whenever choosing a computational method or any other method in general, that we should always start with our research objectives and research questions, and try to ensure that the chosen method or the methods that we are considering to use are appropriate for the set objectives and questions. And here I would comment on, let's say, those sophisticated, kind of complex, especially machine learning methods that are becoming more and more popular recently, not recently, but in the last few years, like deep neural networks. And their questions there about, whether should we use them or not use them. Primarily, I mean, their major advance is that they have high they assure high performance on one hand, but on the other hand, they do not have that level of explainability and transparency. So it's always a question whether to apply such a method or not. And there, I would say we should start with our research objectives and see how relevant it is for us to have a kind of high performance. Is that something that is really in our ultimate objective? If it is, then we should go with such a method. But if we decide to go, then we can do something about it to make the results clear, to make the reasoning behind the results clear. There are already some developments in the machine learning, let's say, community that allow for such things. There is something called ablation studies that allow for, looking into particular, let's say, components or removing certain components of the overall model in order to see how the model performs without them, so that you can estimate what is the contribution of certain components and so on. On the other hand, if high performance is not something that is our ultimate objective, but we also care at least equally about explainability and getting some additional knowledge through our modeling, then we should consider, compare, some traditional statistical learning methods and machine learning methods, and see, if the results that we are getting are not that much worse, then we should definitely opt for those more traditional methods. Especially there is that general principle in machine learning, which is known under the name Occam's razor, which says that if you have multiple machine learning methods that are roughly of equal performance, you should definitely go with the simpler one. Since simpler one is not only, easier to explain later on, but it is also more generalizable, meaning that it would work better with the new data. Also something that related to data, when I'm mentioning data, we should always also consider if the data that we have is applicable. I mean, can we use with the computational method that we want to use? First, is the size of the data set adequate? And this is particularly relevant in the context of machine learning methods. Also, if the data meet the method's assumptions, and there are typically some assumptions typically related to data distribution and so on. Also, when mentioning data, there is something that we should also be aware of, and that is a bias that is often present in the data. That is something that we cannot do much about, but we should definitely be aware of it, and we should consider, is it something that may affect our results and may affect the conclusions that we may draw from those results. Just as an example, I'll give you that example of self-selection bias, which is typical when we collect data through surveys and questionnaires, and especially if they are administered towards the end of the course. So we typically manage to collect responses only from a subset of students. That would be a kind of just one subpopulation that is always not that representative of the overall population of students, but would be those who are typically with higher performance and with higher level of motivation than average. So also something to consider. Also, when I mentioned that aspect about rigorous reporting of our methods and the study results, of course, it is very important, as probably with any other method, that we provide a clear account of the adopted methodology. So to provide a rationale for each important decision that we have made along the way, from data collection, data preparation, all through the model evaluation. And that
Jelena? We're on time, sorry.
Okay, sorry.
All right, it's great that everyone has so much to say. I have the pleasure of introducing our last two panelists. Kristine Lund is a research engineer in the Human and Social Sciences and Vice Director of the Languages Science Laboratory of Interactions, Corpus, Learning and Representations at the University of Lyon. Dr. Lund's research interests include the multimodal co-construction of complex knowledge in goal-oriented computer-mediated human interaction and interactive phenomenon such as explanation and argumentation in problem-solving situations. Following Chris, we'll have Bodong Chen, an associate professor in learning technologies and the Bonnie Westby Hubner Endowed Chair in Education and Technology at the University of Minnesota, also co-director of the Learning Informatics Lab in the College of Education and Human Development. His research interests include the study of computer-supported collaborative learning, online learning, knowledge analytics, and network analytics. Over to you, Chris.
Thanks, Alyssa, and thanks for the invitation to this great panel. So for a long time, I had a printout on my office door of a guy in a white lab coat in the middle of a highly dubious experiment. He was observing a cat and mouse who actually had magnets attached to their paws that allowed them to be suspended upside down from the ceiling on a large metal plate. And I remember taking a marker and writing Rigour on this before putting it on my door. Maybe you get the idea that with my marker, I was mocking what is clearly an experimental protocol, and I was doing that. And for the sake of argument, I'm going to assume that there were 60 of these cat and mouse pairs all being observed in parallel. And now I recognize that doing this can be taken as a straw man argument. In other words, I'm taking a situation that is so exaggerated that I can easily knock it down, right? But in fact, quantitative approaches are often taken to task for not being as relevant as qualitative approaches. And I think Bodong will speak about relevance to practice following my intervention. Quantitative approaches are also taken to task because they allow for causal description, but they are less helpful with causal explanation. And so I will argue that rigor in qualitative analyses help us both with relevance and causal explanation. So first, it doesn't seem that this situation could be relevant, right, to real life existence of the cat and mouse. But we often study situations we think are relevant while disregarding confounding factors that are in fact determinants. Classically, we can even ignore how humans behave. We may put subjects into an experimental condition without taking into account normal reactions that can mess up the results. For example, in a critique of Piaget's traditional conservation task, the experimenter performed an action and then asked the children if something had changed as a result of it, and they responded that something had changed. And only later, the experimenter understood why. It wasn't because the children didn't yet understand conservation of matter. It was because the children thought, well, why would the experimenter ask them if something had not changed, right? And so it reminds you of that old joke where the teacher asked a question in class and Susie says, but teacher, don't you know the answer? And so here Susie has not yet understood the ways of the classroom. And so we find it funny, right? But are we really making the right inferences about the world we're studying? And we are studying human interaction and learning analytics. So when we set up our experimental situations, how do we know what we are ignoring or forgetting about? And how are our assumptions getting in the way of our analyses? These are questions that are answered rather with qualitative approaches. And we want to know in this panel, in our section, how we can report on these approaches in rigorous ways. And so for that, I want to distinguish between causal description and causal explanation. So conceptual and methodological constraints restrict the setup of an experimental situation so that quantitative analyses can be carried out. And causal inference based on causal description requires them some sort of systematic comparison of situations in which the presumed causal factor is present or absent or varies in strength. In other words, the demonstration of causation is like being able to show that there's a regular law-like relationship between two variables, so that a change in the first independent variable results in a change in the second independent or dependent one, right? So it follows that the unique strength of this kind of experimentation is in describing the consequence attributable to deliberately varying a treatment. We call this the causal description, and it's variable oriented. In contrast, though, experiments do less well in clarifying mechanisms through which and the conditions under which this causal relationship holds. And this we can call causal explanation, and it's more process oriented. It's like the difference between knowing that a switch turns on the light and how the light actually works, right? And so as researchers, we should be able to generate knowledge of causality beyond the observed regularities in associations of events. In fact, when we examine large amounts of data, what are we doing? We are studying multiples or aggregates of single instances, and they will not all be the same, even if we might pretend they are by aggregating them. And it doesn't have to be the case that X causes Y repeatedly for how it does cause Y to be a worthwhile question. And causal explanation will tell us which features of the causal relationship are essential to transfer to other situations. And so this is the generalization question that has already been mentioned. So in this very brief intervention, I'm heading to the end. I mostly tried to argue for why qualitative approaches are crucial. And often researchers take the terms used in quantitative research, such as reliability and validity, these terms have been mentioned, and replace them with terms such as credibility, neutrality, confirmability, consistency, dependability, applicability, transferability, trustworthiness, and the capacity to achieve triangulation with different methods. So in addition to understanding your own assumptions about the world and your research, and understanding causal description versus causal explanation, these are terms that you can look up in order to delve deeper into the rigor of qualitative analyses. And I think I'll pass it over to you, Bodung.
Thanks a lot, Chris. Thanks also to editors for trusting me to speak on qualitative research. First of all, I want to maybe take a step back and take a quite little different approach as I think about rigor in learning analytics by saying learning analytics is such a diverse community. We have grown so much in the past 10 years or so, and there's such a wide range of work represented in this community. And if we go back to the original initial definition of learning analytics, we can clearly see maybe two buckets of work in this community, and that has been going on for the past years. And one bucket, as I see, is about applying computational techniques, statistical approaches, data science methods, and so on, however you want to name it, to analyzing and understanding learning in all kinds of contexts. So in that bucket of work, as I see, methodological, conceptual rigor are so important because you have to situate your analysis in literature and you have to pay a lot of attention to your methodological treatments as you carry out that research. And that's very important, as the panelists have already really dived deep into different areas. And also, I want to point out the second bucket of work, which is really rooted in practice. That is about, how to mobilize the discoveries into learning, how to mobilize what we know about learning, and then design and come up with tools and interventions, and then put that into practice so that they can make an impact. And I see a lot of interesting work going on in our community, designing dashboards, for example, or designing, co-designing, especially interventions with teachers and students, and then put those interventions in authentic context and see how that's impacting education. So what I see, those two buckets of work, even though I'm not, they're not binary, but those are maybe two very quite different type of work going on in our community. And I would argue we have to consider different approaches or different criteria as we think about rigor in those two different type of work. And it's not necessarily, as we approach rigor, it's not necessarily always about methodological rigor, but we have to also think about other aspects of rigor that I'm going to talk about right now, and then to really as a starting point for us to consider how to approach rigor differently, especially from a multifaceted point of view in such a diverse community. So if we shift our focus, to the second bucket of work as I described, which is, how to design and come up with tool intervention to improve conditions for learning. And then this enterprise or this work is quite different. And I would highlight that we need to consider relevant to practice, and especially how practice is engaged in our research. And if we aim to design a solution for a group of people, the first idea in terms of rigor that came to my mind was we need to have full disclosure of our educational ideals and our value premises that really motivate our work, that really motivate a specific study or intervention, and why we design a tool, or why we studied at intelligent tutors and so on, and what's the educational philosophy and values behind them, so that we are disclosing, how our approaches to education is built into our tools and our intervention. And I think I see in our community there's a growing literature on how to engage that type of work, and how to engage different stakeholders to in their process of designing interventions. That's just so great. Human-centered approaches to design, that's reflected more and more in our work, and that's what's needed for us to think about rigor in our design work in learning analytics. And second point in terms of rigor, as I consider second bucket work, is as we evaluate, for example, if we put out those intervention tools in the settings and we want to know how it works, and rigors in that case requires our sustained, direct, and systematic documentation of what takes place in that authentic setting. Just like Chris described, we have to, move from randomized control trial. That's really important, don't get me wrong, but also dive deep into what really happens, as we put that in the authentic context, how the students and teachers are reacting to it, how the dynamic local context are shaping the practice that involves our new introduced tool into conversation or tensions with existing factors such as teachers and students and educational regimes. And that's a really complex endeavor. And in education, there's always a debate in terms of whether education should follow science or scientific culture as we approach interventions in educational settings, or we have to do a lot of qualitative work to get at a really understanding of what's happening on the ground. So I'm going to come into the end with that thought, which is we need a lot of qualitative work to document the intervention. That's the second point I made. And the first point I made is we need a lot of approaches to really engage stakeholders as we design or come up with interventions. And that's so important for our field to move forward, especially as we look forward to make a lot of impact in education. Thanks.
Thank you very much, Kristine. Thank you very much for that. Thank you to all panelists. For the participants, please make use of the Q&A tool to ask your questions. While those questions arrive, I will give the floor to any of the panelists that want to answer to any of the other points of view. If you have something to say, we have a few minutes till the questions arrive. Sandra.
Yeah, having listened very carefully to all the panelists, they're all from very different perspectives, computational, statistical, qualitative. I honestly can't see any fundamental differences. The language used might be quite different. Different concepts to do with rigor might have slightly different names, but I really can't see why we couldn't have a consolidated view of what rigor in learning analytics is like. The question I would ask is, if I read a study that is based on computational learning analytics, could I, not being a computational expert, have any insights into the quality of that? And I would say I probably would, in much the same way as I might have insights when I read a history paper, and that these commonalities should really be what we focus on, because I really believe unless we get the act together, we won't have impact. So that's my conclusion after listening to everyone. Happy to debate that.
Yeah, no, I'd like to also follow up on that, Sandra. I really agree with you. I mean, I think we have at least very complementary perspective to this. There are a couple of points I want to make. First point is, and I think somebody also in the discussion or in the chat mentioned, is I think we need to also think more careful as well how we are combining these perspectives. That's something that is really, in my view, very essential. How am I using my computational models with some of the qualitative models? How these models of combinations can be actually mutually beneficial. So for example, Brian Baker is talking about some work to use some of the predictive models or computational models to identify which participants to interview and or potentially use some additional qualitative methods so that we can be in a particular situation where we can get these richer contextual explanations. I think that's really methodologically an important point, but also from the perspective of the rigor, the question becomes how we are reporting these type of things. And to me, when it comes down to reporting, I think we as the field really need to kind of embrace the fact that we are going to talk a lot about data and that our word limits are really not promoting the richness of the data and the types of methods that we are using. But instead, like it's common in other disciplines that at least are close to my field, like computational methods, they always have, in addition to the main paper, electronic supplement, where you can actually report some of these additional data. I'm not really just talking about the charts that we need to append, but potentially additional quotes that cannot easily be fit within the 8,000 words of the JLA limit or 16 pages of the new format of LAC. And we should not basically be having some of the reviewers who are basically gravely offended if you are actually having some of these supplemental materials. If we are talking about the transparency, about the rigor, etc., we need to also embrace the opportunities for people to report in the full extent the data that they are collected so that we can really have some of these issues tackled.
Okay, if there is another comment, we have a pair of questions. So, Lucia, you want to talk? This is a question for Bodo. How you will propose to evaluate impact of an intervention? What is the best way to go? Some precise steps?
All right. Thank you, Lucia, for that question. I think a lot of people on the panel are will have insight into this as well. But you know, there's a pretty big literature in education, also in other field about running interventions and how to measure the impact of that. Of course, in education in the US, in the United States context, it's debated, but there's different guidelines about golden standards, which some institutions will treat as randomized control trial as a way to go. So if you're interested, you can look into those guidelines about how to administer and evaluate an intervention in education. But again, it's debated, and then there's a lot of other ways. I cannot come with a precise and agreed upon approach to do it, but it's definitely worth looking into in our field.
Okay, there is another question that receives a lot of votes. That is how we train the new generation of researchers in this rigor in learning analytics. Some ideas from the panelists?
I can try to take a stab at this question. I think it's an important question. I think we cannot expect that everybody is everything in this particular field. I think we need to have some people who really have strong skills in some of these perspectives, but at the same time also have a clear appreciation for the values, strengths, and or weaknesses of other fields. We often basically have papers that like rejected on the grounds that this is just a qualitative study. Why? Because we need that perspective as much as we need any computational perspective. So I think that level of training obviously needs to include some of these standards. First of all, we need to agree on these standards and some of these rigors on these values. I think the good point for us to start agreeing with these type of things is potentially, well, maybe we can summarize today's conversation in a paper follow-up, and that paper can also potentially lead into a special interest group with SOLAR that is also defining some of the principles. I don't like that we define very rigorous standards in terms of very clear KPIs that we need to achieve, but more in terms of the principles, how these things can be achieved. These principles then should be driving some of our curriculum as we are going forward with these type of things. But I think anybody who is in learning analytics, if they are just taking a single perspective, I think that's ultimately wrong. We need to basically take one perspective, be experts in that, but also have a clear appreciation of the values that other perspectives are also bringing.
So I'm actually going to jump in because unfortunately now everybody wants to talk and we have 3 minutes left and we have to wrap up. But the desire of people to talk, and especially the comments Dragan just made about what comes next, maybe this can be turned into an article or a further conversation, and not laying out KPIs, but trying to maybe articulate in writing some of what we talked about. I'm going to take a quick stab at what I'm seeing and then invite you all to engage further. So picking up on some of the things our many panelists said and trying to pull them together, one of the things that we think about, at least with JLA, is the reporting aspect, rigorous reporting, because you can do wonderful things, but if you don't tell us about them, nobody knows. And so a huge theme I saw across everybody was this notion of explaining and justifying choices and providing a really clear account of the methodology. And so one question I have is, could we articulate a list of the kinds of choices that you should be explaining? Not necessarily how you're explaining them, but what they are. And an initial list that came out from people's comments. First, there's rigorous selection of your data, selection of the model to apply, selection of the educational ideas and values that you are being motivated by, selection of the literature, and alignment and appropriateness across the data, the values, the questions you're asking, and the ways you're pulling it together. And also about the relevance, a rigorous selection of all of these things that are going to be really relevant. In terms of application, there was talk about validation, generalizability, both empirically, but also thinking about it conceptually, things we need to check for: overfitting, bias, disconfirming evidence, consequences of what we're doing, thinking about how we can get more in alignment with each other through replication and potentially sharing and reusing code. That is obviously very quick and just from this session, but I saw a lot of things that we could at least put out as a non-comprehensive, but a starting point about things you should be thinking about sharing. There's so much that we do when we think about our studies that doesn't make it in, and maybe there's places with addendums and even in the journal articles themselves that we could report on this better. With that, I will leave you with two things. One, if you're interested in knowing the article that kicked all of this off, that we are hoping to follow up on another article with, I just dropped a link in. This was the JLA editorial from fall 2019. And I know everyone wants to say more things, so this is not the end, but the beginning. And the link I'm gonna put in a couple of times. There's a form that's all the same, but please click on any one of those 3 links. It's a very quick form just to share your name and what kind of session you'd be interested in participating. We're gonna try and do groups across different time zones that work at nice times for everybody to engage in some smaller conversations so that the couple hundred of you who didn't get to speak today have a chance. And we hope that all 6 of our panelists will want to engage more because I know you have more to say. I think with that, I'll turn it over to Vita to close us up.
Yeah, thank you everybody for attending, and thank you all presenters and JLA editors for chairing this wonderful session. So today, so now we are closing the session. I've put, if you want to be notified about the future webinars, I put a link to our newsletter. We run these kind of events about every 2 months, and all kinds of other things you can get informed as well. This session will be also recorded and posted to Solar YouTube channel, so you're going to have the recording there as well to share with others, and you also can take a look at all of the other webinars that we have from the past. And yeah, with all that, thanks once again to everybody, and hope you see you in the future sessions. Thank you.
Thank you.
Thank you, everybody.
Thanks.
Thank you.
Have a good day or night.
Bye.
Thanks, everyone. Lots to think about.